These are the notes for section 1.2 in chapter 0. And we're going to be going over example 3 and also example 4. So let's go ahead and look at example 3 together. It says figure 1.2d, so the graph here, shows a graph of p of x equals 40 times 0.6 raised to the x power. And this represents the probability that it rains a number of inches x at a particular place during a particular thunderstorm. Okay, so as you look at this graph, you can kind of see that the probability that it would rain, 1 inch would be somewhere, it looks like it's about between 20 and 30%. The probability that it's going to rain 2 inches, between 20 and 10%. 3 inches, you can see it's decreasing with time, which hopefully would kind of make sense. Probability that it'd rain 1 inch is going to be greater than probably the probability that it'd rain 4 inches. So it says the probability that it rains 1 inch, so P of 1 equals 24%. Okay, so if you were to plug 1 into this equation for x, you would end up getting out 24%. And they're going to ask you by how much and in what direction does the probability change from x equals 1 to x equals 1.1. What is the average rate of change from 1 inch to 1.1 inches? Make sure to include units in your answer. Why is the rate negative? So we are going to be basically trying to find the derivative at this point pretty close to it. We're going to get a very close approximation. So let's go ahead and look at that together. So I'm going to do the work below this problem. So let me move down a little bit here. All right, so for part A, start over here. We're going to be finding, it's still the average rate of change, but it's, it's getting closer and closer to the instantaneous rate of change. All right, so we're going to go ahead and answer that first question there. So what we're going to want to do is we need to find f of 1.1 minus f of 1 all over 1.1 minus 1. Okay. So this is going to be our average rate of change. Okay. All right, so I'm going to actually use my graphing calculator so that I can keep my answers exact as I work through this. It's really important that we understand how to use a graphing calculator, how to kind of use it appropriately. So in this case here, I'm going to go ahead and go to y equals. And if you have any equations in there, go ahead and clear them out. And I'm going to enter in the equation that we have. So I'm going to enter in 40 and then 0.6 raised to the x power. And I need to get some different values for this. Now what you could do is if you have, let's see, hit second window, so you go to your table set, you'll notice that for mine, I actually have my independent variable, so my x value is at ask. So that means when I go to my table of values, I can actually enter in, 1 and get out what the value would be. I can enter in 1.1 and I can get out what the value would be. Now to keep this really exact, I'm going to actually use another part of my calculator that will do all in one go the top part of this slope that we're trying to find. So I'm going to move this up a little bit so you can see what I'm doing on my calculator. Since I have this entered in for y1, what I'm going to do is go back to my home screen, and if you hit vars, it might be a little bit different depending on the calculator you have. You go over to y vars, you want to choose function, and I'm going to say y sub 1, and I want to find the value of 1.1, so I'm basically kind of using function notation here. I'm going to say minus, go back to vars, same thing again, go over to y vars, choose function, we're still working with y1 of 1, okay. And I'm going to hit enter, and there's the change in y on the top. I'm going to say divided by 1.1 minus 1, enter again, and you will actually get your average rate of change all on your calculator, keeping the answers exact instead of making rounding errors throughout the process. On the AP Calc exam, they always ask that you round to 3 decimal places, so in our class we'll also be doing the same thing. So our answer would end up being negative 11.952. They also asked what the units would be in our answers. So again, you want to think about, okay, what was the units for the change in y? Well, it looks like the units for the change in y was a percentage, and it looks like the units for the change in x was inches. So that would be the answer to part of this. And it also asks, it says, why is the rate negative? Basically, the rate is negative because the probability decreases as the number of inches of rain increase. So I'm going to put that on the side over here. So the probability, or excuse me, the rate is negative because the probability decreases as the number of inches of rain increases. All right, go ahead and look down at letter B. It says write an equation R of x, the average rate of change of P of x from 1 to x. Okay? Make a table of values of R of x for each 0.01 or 1/100th unit of x from 97 hundredths to 1 300ths. Explain why R of x is undefined at x equals 1. Okay, so we have several things to answer again. So I'm going to move this down a little bit. And let's go ahead and work on letter B. Okay, so the first thing I want us to write is this equation R of x. Okay, so I'm going to write R of x equals, and if you think about your average rate of change, what you're doing each time, if you look back up here, is we're going to be entering in some value, some rate of change either after 1 or a little bit before 1. So I'm just going to leave it as our equation was actually defined as, this probably should have been up here, p, because it was not f of x, but it was p. So I'm going to say up here that it's going to be p, some value for x, okay, whether it's going to be 1.1 or whether it's going to be 0.99, minus, and we're always subtracting the same thing, so I'm going to say it's going to be p of 1. And on the bottom, again, this value here is going to be changing, so I'm just going to call it x, and it's going to be minus 1. Okay. So I'm going to, again, use my calculator to help me find these values to keep them pretty exact. Before I plug it in, let's kind of think about how we're going to make this table of values. So I'm going to actually do it over here on the side, and I'm going to use a different color so it's a little bit easier to see the difference. So I'm going to go ahead and label one side as x, and the other side is R of x. Okay. And they're asking us to go from 0.97 in increments of 1/100th, so it's going to be 0.98, 0.99, 1, 1.01, 1.02, and 1.03. And I'm going to go ahead and plug this equation into my calculator. So again, I'm going to go back to here, and I go to y equals, and I'm going to use my vars to pull up y sub 1. So I'm going to say, and actually put this top part in parentheses. So vars, go over and grab y sub 1, and it's just going to be y sub 1 of x, okay, minus, go back to vars, grab y sub 1 of 1, okay, close parentheses, divided by x minus 1. Okay, so that's exactly what I have. We look at over here what I had for my equation R of x. Alright, so I'm going to go to my table of values, and I'm going to keep it, my table set is going to still be ask. So I'm just going to plug in what I have, so what I need to get. So I need 0.97, and I need 0.98. I'm going to need 0.99, 1, 1.01, 1.02, and 1.03. Okay. I'm looking at y sub 2. Okay. So for this first one, And again, we're going to keep it rounded to 3 decimal places. It's going to be negative 12.354. The next one is negative 12.323. Next one's going to be negative 12.291. And we have an error here. We'll talk about why that happens a little bit. And then we have negative 12.229, negative 12.197, and negative 12.166. Alright, so I've got my table of values. It says, explain why r of x is undefined at x equals 1. Well, if you think about this logically, if you're plugging in 1 here, you're going to end up having it over 0. So I'm going to say r of x is undefined at x equals 1 because you are dividing by 0. Alright, last part here. It says instantaneous rate at x equals 1 is the limit the average rate approaches as x approaches 1. Estimate the instantaneous rate using information from part B. Name the concept of calculus that is given to this instantaneous rate. Alright, so part C down here. And again, I'm going to move this up a little bit. Alright, so for part C, we're going to basically, if you think about this instantaneous rate of change, you want the change in x to be as small as possible. So I'm going to go ahead and average when it was 0.99 and 1.01, because that's basically the change in x is, as small as possible. That actually still works. So down here, I'm going to write that I'm going to average r of 0.99 and r of 1.01. Okay. And this instantaneous rate of change is going to be approximately, I'm going to average the two together, so approximately half of negative 12.291 plus negative 11.952. Okay, it's approximately negative 12.2598, so go ahead and round that to negative 12.260. Okay. And we are again measuring in percent per inches. And this instantaneous rate of change is called our derivative.